Update 4 brought us many new features to play with, but the most useful is definitely the power switches and battery backups. Whether you're working with a spaghetti factory or going for a clean industrial look, knowing how to use the new power switches can make any factory much more efficient. So in this video, we're going to go over the key things to know and look at a few examples to give you some ideas. Right off the bat, power switches will not magically fix an imbalanced energy setup. After some testing, even with separated blocks, if your power consumption exceeds production, the whole grid goes down, not just an individual block. While personally, I wish this was a feature of the switches, their intended usage is to block off different sections of the factory for you to shut off in a shortage, instead of having to run around and shut off machines one by one, and then hopefully remember which ones to turn on again later. While this is definitely useful in the early stages of new factories that don't have a stable power supply, for any longtime players of Satisfactory, this may not seem immediately useful if your factory is already set up and reliable. However, that's not the case, as there's a clever way to use this that can let you reroute resources. Here's a basic example to demonstrate the concept. Say you want to process iron products or steel beams and pipes. Naturally, you can split the ingots equally to two different sets of constructors. This will give you a decent supply of both parts. However, what if you want to prioritize steel plates instead to fulfill a demand elsewhere in the factory? You'd have to go one by one and reconfigure the constructors by hand. Then multiply that effort for assemblers or manufacturers that require changing multiple resource inputs. And as fun as that sounds, here's an alternative. Let's say you build 8 constructors for both parts, making 16 total, and we'll block both sides off with power switches. You may see where this is going. So even if your ingot supply can only support 8 constructors at once, you have the option to keep both on and get a healthy mix of parts, or if you want to prioritize one over the other, you just go and shut off the power switch for the block of unwanted parts. It'll take a minute for the powered down machines to stop pulling resources on the conveyor belts, but after this transitioning period, you'll have doubled production of your desired part by sending 100% of your inputs to the functional block. Again, this is just a simple example with a constructor, but by applying the same methodology to more complex recipes that use similar parts, you can control the flow of resources from a distance without having to make conveyor spaghetti. For extra style points, you can set up a power control tower to monitor the blocks. I recommend using the new lights and color coding different sections as well. This will make it easier to tell at a glance what you've got running without having to check each switch individually. Next up, we've got batteries, which everyone should be using. Batteries charge in real time, and it takes an hour for one battery to fully refill. But here's the catch. It caps at 100 megawatt hours, which means if you used exactly 100 megawatts of power without any generators, the battery could keep any connected machines running for an hour before needing recharged. But that doesn't mean it caps out at 100 megawatts of allowed usage. You can go higher. To show a quick example, this is a manufacturer that I've overclocked with 3 power cores. That comes out to a total power draw of 238 megawatts. So let's start the machine and walk over to our battery to see the real benefits. In this screen, you can see exactly how much time the battery has left at the current consumption. Overdrawing past 100 megawatts simply shortens the amount of time the battery supplies power, and once it runs out, you'll hear that dreaded sound of everything shutting off. Essentially, batteries are going to give you extra time to solve any problems. And another way to look at it is, if you have an unstable power grid that occasionally spikes, say when your 10 overclocked manufacturers have enough resources at the same time, the batteries will kick in and fill the gap to keep the factory running at peak performance, until either consumption falls to normal levels, or the whole grid collapses. Drop a like if you learned something, and be sure to tune in next time when we continue trying to break Evil Genius 2. Thanks for watching.